Hello, everyone. Thank you for coming to Dallas Startup Week. Today, we have Steven Anderson for this session. How many of you know who Steven Anderson is? Very good. For the other ones who don't, he is the author of Seductive Interaction Design, which is one of the top 10 books in the world for user experience. So we're very glad to have him today. And he is going to be walking through his workshop. Of course, he'll tell you more about it, about a new book which he is designing or creating. And so you're going to get hands-on for that. But of course, before we start that, I've got the sponsors I need to thank. So, of course, for Chase, Downtown Dallas Inc., Vela Wood, Touch Titans, Dev Mountain, Circus, Kratos, and also the Wi-Fi is provided by Cogent and Opus 3. So thank them. And if you want to catch any other sessions in this room is live streaming all day today and tomorrow. But for now, let's give it up for Steven Anderson.
So the first thing I'm doing here is setting my personal timer. I am taking about a 3-hour workshop and compressing it to 90 minutes. So if it feels fast-paced at times, it's because it is. Also, we had limited tables, so this group will be most actively engaged. However, the way the workshop's set up, it's going to be about 50-50 between me lecturing and you doing hands-on activities. And the activities are thin 5- and 10-minute slices, so you guys can follow along as well. So a little bit about that. And just about the subject. So the title is Making Sense of Stuff, and I purposely chose that word stuff. You can put anything in there. Making sense of stuff with visual models. And the book I'm working on right now with my co-author Carl Fast, it's all about the architecture of understanding. How do people make sense of too much information? And the chapters I'm working on right now are about what I'm going to talk about today, which is using external visual representations, models, to make sense of stuff. And it's not just lecture. I'm actually going to go through hands-on some languages I've developed and uncovered to help make sense of visual models. And I'm going to stop explaining. And actually, I figured the best way to kick things off was actually start with an exercise. So at the tables, you all have paper. If you have a notebook, you'll need that. If you don't, I have some paper up here that you're welcome to grab and use. And you'll need to pair up with someone for this first exercise. If you need paper, just raise your hand. We'll get some going around, or a notebook will be fine. All right, pair up with someone. We're going to play a quick game, and by quick, I mean 2 minutes. And here are the rules, all right? So here's how the game goes. Actually, before I read anything, just write down the numbers 1 through 9 down the sheet of the paper, vertically, just like you see on the right here. Jason, do you need just one of you? Yeah, this is the game board for you guys. I need my pen back, Jason. All right, so here's how the game's gonna play. You'll write the numbers 1 through 9 down on a sheet of paper. Most of you have done that. Just one paper per team, per pair of folks. You will each take turns selecting numbers from this list that you just wrote down. And you'll take turns, so one of you will start and pick a number and cross it off. Maybe one of you crosses it, maybe one of you circles it, so you know who marked it. If you're at the table, you can use colored markers. You can pick a color, however you want to do it, right? The winner of this game is the first person to have chosen exactly 3 numbers, no more, exactly 3 numbers, which add up to 15. So as you pick your numbers, there's also a bit of strategy. You have to think about numbers that are going to add up to 15. All right? For example, if I selected 9, and you selected 3, and I selected 6, and then so on, you would win because 3 plus 8 plus 4 equals 15. Make sense? All right? So you're picking 3 numbers that add up to 9. On your mark, get set, go. All right, if you blocked yourself or someone's won, just write it down and play again, all right? It's a fairly quick game. You blocked yourself, can't add up to 15? You guys can pair up and play with someone next to you. take turns. We're taking turns. It's like tic-tac-toe. 20 seconds left. Start over. Yeah. Yep. Okay, let's do a different game. So in this game, you need to draw the 3x3 magic square, so just like you see up here. And here's what's beautiful about the magic square. Oops, let me get out of the way here. If you write this out, you'll notice that in any direction, horizontal, vertical, like it adds up to 15, which is kind of cool, all right? So write that on a sheet of paper. This time, as it says, the rows, columns, and diagonals all add up to 15. And moreover, every way of writing 15 as the sum of three numbers from 1 to 9 is represented in this magic square. So write that on the sheet of paper. When you choose a number, one of you draws an X over it. When the other person chooses a number, draw a circle over it, all right? I think you see where this is going. All right, go ahead and play this game. 2 minutes. Yeah. And if you finish playing, play again. All right, we actually don't need the full 2 minutes to finish, to make the point. These are exactly the same game, all right, except I think I heard it at a couple tables. This game's easier, the second one. And the question is, why is tic-tac-toe so much simpler? And I'm gonna earn some street cred with the engineers in the room. These games are isomorphic to each other, meaning they're exactly the same, they've just been represented differently. And the reason tic-tac-toe is easier is it's a visual model that more easily reveals patterns. And so there's some benefit to putting stuff on the paper. For example, if I said play this game in your head, you can't use paper, that'd be really hard, right? So just writing numbers down on a sheet of paper and being able to record them, that makes it that much easier to understand. But then taking another step and actually putting them in a model makes it even easier to understand. There's less information in the head and more on the page. And so that's why I wanted to open with this exercise, is I'm talking about visual models, but really it applies to anything. Any place where we can offload information out of our brains and get it onto the page so we can reveal patterns. And so we create models in lots of ways already. Charts and diagrams, if you work with those are visual models that we work with. Data visualizations of all kinds, bubble clusters, the things that look like hairballs that got coughed up, right? Those are visual patterns or visual models that reveal patterns. We have all sorts of abstract patterns we use in business conversations, like the XY matrices, Venn diagrams, cycles, comparisons, things like that. We also have models, templates, and frameworks. Usually other people have created them and we fill them with our content. So you have things like the business model canvas. At any company at the highest level can fill in these 9 boxes and understand their business. Customer journeys, if you work in design or UX or service mapping, all that type of stuff. Gantt charts, if you do project planning. Even things like 9-grids analysis, if you use 9 grids to assess employees and performance, site maps, all these types of things, and much more. There are dozens, potentially hundreds more. These are all visual models to represent information. And my point with this slide is to say this stuff is relevant to everyone in the room, right? And if you don't see how, see me at the end, I will convince you of that, all right? There are also models that aren't ready to use off the shelf. They're ones that we create often in the moment, or we create in response to a question. So here was one my friend Chris Fahey created to explain whiskeys. And I can just imagine, I wasn't there, but I can just imagine he and a friend saying, now wait, is difference? What's the difference between a whiskey and a rye and a bourbon? I think, Jason, you and I have had similar conversations, right? And so Chris mapped it out and said, okay, here's the drinks you get, but everything starts in either Scotland or USA, and everything starts with malted barley, but then the percentage. So he explained how you end up with these different whiskeys through a visual representation. And I saw this and I was like, oh, I get it. This makes sense. I wish I'd had this when we were having our conversation. I created this model years ago. It was based on Maslow's hierarchy of needs, but it was to explain the maturity of any space. And it's the UX maturity model, or UX hierarchy of needs, from functional, useful, all the way up to it's meaningful in my life. So I created that model to explain different ideas. I love this one. I'm a big coffee fan, but I had trouble understanding all the different types of Italian espresso drinks until I saw this model. And I was able to look at it and go, oh, I get it. Everything has an espresso shot. Some things have milk, some things have water. What you do with the milk is different. One of those drinks, the mocha, has chocolate added. Okay, I get it. And here's another one. So it's not just models on paper and stuff, but we have models in other places. So this is a bad model, and not just because it's hard to see in the lighting. This is a street sign. If you parked around here, you probably were scratching your head trying to understand the information on the street signs, right? Well, a designer in San Francisco actually took this on and redesigned these street signs in a way where you can look and go, oh, I get it, right? So this is our 1 through 9. This is our tic-tac-toe model, right? It's much easier to make sense of. And this really is the heart of the book I'm writing. Again, it's all about the information we have. We're given lots of information, but it's kind of like puzzle pieces where no one has taken the time to either put it together for us or give us the tools to put it together for ourselves. And so the book is all about different ways we can do this, and everything today is from the 2 chapters on visual representations. All right, so we have all sorts of models we use, models others create, all sorts of visual models. And the way the statement I like to make is external visual representations, nice academic term there, are critical tools for making sense of complex information. But there's a problem. This is what I've noticed in the last decade or so of working with people on this. You look at all these models, and for the ones that are ready to use, the models that people grab off the shelves or the models that are built into Excel or built into different tools aren't always a good fit with the data we have. Like, we use a graph, but really it's probably not the best way to represent something, or we use a particular plotting tool that's probably not the best. It's not a good match with the data. The other problem is when it comes to creating our own visual models, a lot of people don't know how to use visuals to explore different subjects. There's no visual literacy. How do we work with visuals in a way that clarifies information and doesn't just decorate information, right? So this is the problem I've seen. The good news, and the reason we're all here today, all of these models and the dozens more not shown, all of these models build upon a common set of underlying visual elements. And that's what I'm going to share with you. That's what you're going to work with today. Again, 90 minutes, there's not a lot of time to go super deep, but you'll get a taste of this visual language that I'm referring to. And just to make this clear, if you're doing a service blueprint like this, which is all about a customer journey and the experience, this was for a retailer, it was their site-to-store experience, or if you're doing crazy data visualizations like this, all of these models build upon a common set of underlying visual elements. That's one of the big takeaways from today. So let's get into it. Using visual models or using visual properties and spatial arrangement to make sense of complex ideas. Before we do, to make this really relevant to you personally, I want you to do a bit of self-reflection and brainstorming. And I want you to list some things you're working with that could benefit from a good visual model. Things that are complex, confusing, maybe they're confusing for you, maybe you have difficulty explaining them to others. And if you're not sure, if you need some things to jumpstart, these are things I either have or would like to create visual models for. So everything from the whiskey one to how public key encryption works. I actually created a model to help me make sense of that. UX prototyping tools, at last count, there were like 50 prototyping tools or frameworks, and it's hard to assess the pros and cons of each. So all sorts of things, making sense of medical bills, right? I think this is a fairly universal problem. When I do the all-day workshop on this, the top two things that most people list are making sense of my retirement plan, my 401k, closely followed, and this is probably coupled with this, closely followed by how do I make sense of all the wine options at my store? All right, so anyway, take about a minute and a half and just do some personal brainstorming, list some things you're working with that are kind of complex that could benefit from a visual model. It could be at work, it could be personally, whatever. "20 seconds left. All right, so normally at this point in a longer workshop, I would go around and ask people to share what they wrote because I'm genuinely curious in the types of problems you have. But this is the insane 90-minute workshop version, so we are going to skip to the next exercise. Just a little bit of what to expect for the next 60 minutes. So 20 minutes, set up an intro. We are exactly on time. Woohoo! It's rare for me. We're going to do a workshop that builds through, an exercise that builds through 3 levels. So I'm going to give you a challenge. And the first round, you're going to feel pretty good. It's confidence building, right? Just like a game. And then I'm going to add a twist to it, and it's going to be a little more challenging. And then I'm going to add another twist to it, and it's going to be bewildering and overwhelming and confusing, right? And we're going to use that to then, I'm actually going to spend the last 30 minutes to actually talk about some of the stuff that will make these types of visual challenges easier. All right, and for those of you who aren't at a table, you can follow along. If you want to pair up with someone, you can do that as well. You don't have the benefit of the table, so when we get to this exercise, it will be a little bit odd, but you can still get all the information that you want to get from this, all right? So here is the workshop challenge. We are a super secret government organization, all right? And we've got to keep a watch on all these mutants, this mutant outbreak. Right? We've got all these people with powers and their DNA and stuff. You can imagine X-Men, you can imagine heroes, whatever you want, right? But we are the organization that does not have these powers, and we need to, keep an eye on them and watch out for all these mutants. So what we need you to create is we need you to design the system that will track the geolocation of mutants around the world. So it's a map. The mutants are represented by a pin on the map. And at this point in time, there are only a few known mutants, so there's not a lot. So that's just telling you how much data we have to work with. And there's only 2 points of data that the pen that you're going to design needs to represent. One, the mutant power level classification, 1 through 5. 5 being like they've got a serious power, like they can go bend metal and lift up a San Francisco bridge and destroy it, right? 1 is they can glow in the dark, right? It's something pretty non-threatening we don't have to worry about. So the mutants have a rating from 1 to 5, and then we want to know the mutants' affiliation. Are they good, are they bad, or neutral/unknown? So some sort of indicator. Now, probably a lot of you are like, this is easy, I can jump at it. So let me throw a little bit of a twist in this. You can't do this as your representation. All right, I know a lot of you half of you were thinking about this, and then the other half of you were saying, well, what about this, right? You can't do either of these. I want you to think about other ways you could represent these 2 points of data. Again, each mutant is a pin on a map, and you want to make sure the pin represents those 2 points of data. Now, before I just throw you to the wild, there is a structured, almost scientific way to go about this. There's a sheet that you have at the table. Those of you who are over here, I actually have enough to pass around and sort of share. So let me do that. There we go. Yeah, if you guys want to give me that. So there's not enough for every one person, but if you, like for every 3 of you, if you kind of share one, you can follow along. So this is a list of about 30 or so visual encodings. And visual encodings are pretty awesome things. They're the things that our eye picks up on before things even register in our conscious working memory. So things like shape or color or outliers. Like I can show you a screen with 100 circles on it, and one circle will be red, and your brain will pick it out in milliseconds. These are visual encodings. Yep. Yep. Oh, gosh. There are versions of that that have been made accessible, yeah. But the same thing goes with shape. Like if I had like 100 squares and I had one triangle in there, the eye can pick it out very quickly. So visual encodings are really powerful for aiding in perception and seeing these patterns that we were talking about. What a lot of people do is they start with, well, I think we should use color to represent, good, bad, or neutral, or I think we should use scale to represent, the 1 through 5 or things like that. And a lot of us start with the encodings themselves. The better way is actually start across the top and ask, that point of data that Stephen gave us, is it a category? Is it precise, quantitative? Is like a number, like we need to represent 1.73, right? Is it general quantitative information? Like it's sort of like this, right? Or does it show sequence? And those are like the 4 functions of visual encodings. And so what I encourage people to do is start with the function of a visual encoding and then find one that maps. So the way to go through, we'll do this together. Mutant power level classification 1 through 5. What do you think that is? Is what? You might say precise quantitative, but actually 1, 2, 3, 4, 5, what is that? Sequence, yeah. So I would say that's sequence. And so then things you could use for sequence would be orientation, form, size, area, aligned in, all the things listed on the chart. So you go down, you find a solid green check, and you go back and you can see what works well with sequence. Whether this mutant is good, bad, or unknown, sorry, I kind of gave that away, but that is category, yeah. And you can use colors, iconography, form, line width, etc. Right? So that's the kind of structured scientific way to approach this problem. Again, you can't use that or that, okay? Can't use those two. Animations. And 7 minutes to explore multiple options. Go. But yeah, do this as a group, a table exercise, or if you want to pair up with someone, or if you're feeling like a loner, you can do it by yourself too, that's okay. However you want to do this exercise, as long as you get some value out of this time. And those of you at tables, if you want to do this with in groups of 2 or 3, that's fine. If you want to splinter off, that's okay. right, less than a minute left, and then we'll move on to the next level of this workshop challenge. Ten seconds left. Okay, again, if we had more time, we would share and learn from each other. That's one of the big advantages of workshops, is getting to see what the ideas that other people came up with. One idea I've seen that I like is this one, using shape and color to reinforce the idea. And that gets back to the color blindness issue you brought up, which is if you can't quite recognize the color, at least you can recognize the shape. In fact, the shape probably is more easily recognized. All right, so that's level one of this exercise. The whole point is to get you thinking in a more scientific way or critical way about which visual encodings to use to represent information. Now let's level it up a bit. And this is probably what happens with a lot of client projects, where it's like, oh yeah, we got one thing we forgot to tell you. And they usually tell you at the 11th hour, and they're like, oh, I needed to know this earlier. So that's what we're going to do. So it's still the same design, the system that will track the geolocation of mutants around the world. So there's still a map. You're designing the pen. The first two data points are still the same. So the mutant level classification, 1 through 5, whether this mutant is good, bad, or unknown. But there's a third point of data I want you to represent now in that little pen. So if you were feeling good representing 2 points of data, now you've got to add a third point of data, right? So this is where it gets a little more challenging. We want to know, we want some information or indication of activity, incidents, mentions in the press, on social media. We want to know if this person is getting attention. Good, bad, doesn't matter, just are they getting attention in some way? And so if we go back to our model, this one is actually interesting, because I think we could probably, most of us agree, sequence and category fit those two things. But when you talk about activity, incidents, mentions in the press, now you've got to decide, as an individual or with your partner or at the table as a group, do we want to have sequence here, from very quiet, no mentions, to really loud, they're on the news all the time? Do we want to show general qualitative information, just some sort of using size to indicate how much attention they're getting, but it's kind of a general, there's not precise information? Or do we want a very precise thing, like they got exactly 377 mentions on Twitter last night, or whatever it is, right? Retweets. You get to decide and then figure out how to best represent that. So this happens a lot, where it's not always cut and dry. What kind of information is this? And so you have to make a decision. Is this going to be sequence? Is it going to be general qualitative information, or precise quantitative information? This, by the way, this is where I often am sitting across from the table with a data scientist. And whatever it is, if you've gone through a data science program, they beat into you that everything has to be precise quantitative information. And so that's why pie charts are bad and bar charts are good and all this stuff. And I'm like, well, yes, if you're trying to represent precise quantitative information. But if you want to show general qualitative information, pie charts are okay, right? There are other things that are okay. It just depends what your aim is and what you're trying to do. All right, so again, 7 minutes. You'll probably need the full 7 minutes this time. You're showing these 3 points of data on that marker, and those two things I put off limits earlier, like the color and the number, those are open up to you now. So you can use that as a base if you want. Just trying to allow a little more freedom. 7 minutes, go. Okay, 20 seconds left. Okay, so level 1 was meant to be confidence building and introduce you to the ideas. Level 2 is supposed to be a bit more challenging. Did you find it a little bit more challenging, the level 2? Some of you? Okay, yeah. And so there are a couple thoughts before we go to level 3, which is meant to be like head exploding, right? There was something I locked down implicitly. I didn't call it out, but there's a piece of data I locked down. You had no control over it in this, and that was the map, the geolocation. And I defined that as a point of data. Like you put the pin on the map somewhere, and that's another point of data that's just defined by placement. As this type of model works when you have dozens of mutants around the world, but there's an explosion now, and there are hundreds of mutants, and there are dozens in a city. So then you run into problems like, do you have like 50 pins all overlapping on one city, or do you have to zoom in to actually get that data? And the geospatial sort of model just doesn't hold up. Also, 3 points of data, we need more than that. We need more data on these mutants, right? And so level 3, you have to design the system that will assess, notice I crossed out geolocation assess the mutants around the world. So level 3, the mutant outbreak is upon us. There are hundreds of mutants around the world, and they're on the move. We need a visualization that makes it easier to assess more points of data. Geolocation isn't the critical point anymore. And there are 5 points of data now that we want you to represent. The power level, 1 through 5, whether this mutant is good, bad, or unknown, activity incidents, mentions in the press, so all of that you're familiar with. Their last known location, so we still want to know, the geolocation, but you can represent it in some way other than a map. In fact, I'm going to say don't use a map this time, right? And then age. Someone on the team wants to know their age. Are they kids? Or are they teenagers? You got to watch out for those teens, right, with powers. So anyway, those are the 5 points of data we want to know. Also, if it helps, this question comes up when you really get into the nitty-gritty. There isn't an equal distribution of 5s, 4s, 3s. Like, there are going to be far fewer 5s than there are 4s and 3s. Lots of 1s, right? Lots of kids who can glow in the dark. So if that helps, that's a point of clarification I wanted to add. Now, before I say go at it and I give you 12 minutes, more time to work on this, let me give you a bit of instruction and a way to approach this problem. So I want to start off with a model we're all familiar with, a map, right? Forget the mutants for a second. Think about yourself creating a map of all the places you visited. And so you might put push pins of all the cities or the countries you've been in. The reason I start with a map, it's an easy illustration for a very fundamental concept I want to drill in your heads. And that is, think of the pins and the things that move around on the map as objects, and think of the map as substrate. Academic term, I used to call it the base layer, but I want you to think of this idea, objects and substrates. And it doesn't have to be a map, right? If we go back to our tic-tac-toe game, it follows the very same pattern. The X's and the O's were objects, and the board, the grid, was the substrate. See that? Right? And you put marks on the map, in this case, the model there, right? Even things like this, like there aren't discrete map points. This is a visualization from, I want to say New York Times, that was talking about all sorts of data and trend data on the jobless rate, and you could filter it in all different ways up here and get different graphs and hover, and it would light things up. Really powerful and complex, but this model I'm talking about, object, substrate, same thing. It just happens that the object isn't a single point, it's a line, a series of points. And so if we split it out, you have objects, and you have a substrate, the model that's mapped onto. In this case, the substrate looks at values and looks at time. Those are the 2 dimensions. So with this exercise or this level, I want you to start thinking about the model underneath, the substrate. Before I defined it for you, so I constrained the problem by saying it's a map, so you didn't have to worry about it. But now you get to think about, well, what would be a good substrate to represent data and information? And here's the hardest part of doing any visualization, is deciding which data goes where. Because if you're looking and you have all this data, and again, this is the personal example. So places I've been, like right? Places I would like to visit in the future that I've not been to. If I went to it, when I went, so the date, right? Places with good food. So I'm a foodie, so I like to remember places by food and what food I had there. Places that speak English or not. Relative strength of the dollar and so on. So you might have all these things you want your visual to represent. And you might say, you know what, a map just doesn't work. And you may say, okay, well, what other options are there? Well, maybe you want it to be timeline based. Like you want to show a progression over time of all the places you went. So you have context of time, and that's more important than geolocation. Or maybe it's some crazy thing. You want to show the overlap of power of the dollar, how much you enjoyed it, and food, right? And see if there's some common denominator. So you use the Venn diagram or something like that. Maybe you want to put it on a matrix, like how much it cost versus how much you enjoyed it. You know, some sort of thing, but you've got to make a choice which data goes in the model, in the substrate, and which data goes in the objects. And this is the hardest part, because you get in a lot of playful scenarios where you move data around and you see what works better, and you try a different model, different substrate. It's the hardest part of doing data visualization, is figuring out where you want to represent the data. So going back to our scenario, here's the way to think about it. You have, they don't even have to be pins literally anymore. They can be whatever. You have these objects that are placed on some sort of substrate, and you need to represent, whether it's in the substrate or the object, these 5 dimensions of data that we already went through. So now you've got to talk about as a group, where do we want to represent it? How do we want to represent it? I normally might provide a bank of like 50 different models to think about, but actually I'm going to just throw you to the wild and see what you come up with based on patterns you've seen before, and then we'll look at that, all right? So 12 minutes to come up with a model that represents these 5 points of data. Again, think about what data goes in the substrate, what data goes in the object, and if you feel bewildered, like your head's exploding in 12 minutes, because that's an insanely short amount of time, that's okay, all right? Have at it. Yeah, and just to be clear, no maps in this version, no maps. Like a model, a substrate, but not a literal geographic map. So a bit of advice, if you haven't experienced this yet, this exercise calls into question what data do you value most? And oftentimes the data that's most important is the data that goes in the substrate. Like that, like if it's let's see, good, bad, unknown, like that might be your substrate where you group people in those 3 buckets, right? But you often have to decide as a group, what is the data or the 2 points of data that we value most, and that usually goes in the substrate. Okay, a minute left. Okay, we could definitely go on for another hour with this exact exercise because this is where there's all sorts of creative possibilities. If we had more time, what I would do is have everyone get up and look at other ideas because I think every table had new, slightly different ideas. I know this is engaging, really exciting, which is a confidence builder for me, but if I can have your attention, I'm gonna give you some more useful stuff and ways to handle this. There are two ways to respond to this, or let me start with the way most people respond to how do you come up with a good model. Most books that talk about visual thinking or sketchnoting or visualization or anything related to the subject, what they usually show you are a bunch of patterns. And those are great. In fact, I have a Pinterest board and a folder, and I have places where I collect anything that I need for inspiration that might trigger a pattern. And if you've done any research into creativity and how we come up with new ideas, we don't really come up with new ideas. We come up with remixes of ideas we've accumulated in our brain. And so one of the ways to be more creative and have more ideas is to fill your brain and expose yourself to a lot more different visual models. In fact, I'm willing to bet if I challenged you to say, did you come up with something wholly original or were you drawing on prior experiences? Most of you, whether you realize it or not, would say, oh yeah, I was drawing on prior experiences. Like I was pulling together a model I've used here or I've seen here and I'm trying it with this problem. So that's one way to respond, and that's how most books and most people respond. To me, if I use a chemistry example, it's a bit like explaining compounds to people, the mixes of elements and stuff, but never actually going the layer below and saying, okay, well, let's talk about the periodic table of elements. Let's talk about the things that make up all of these compounds and all these things that are combined. You talk about these patterns, but how did you create this pattern in the first place? And so that's what I want to share with you, is I feel like I've taken it a layer deeper to talk about the visual language that underlies the spatial arrangement of things. And so if we go back to this model, so substrate object, remember that? I'm going to introduce another phrase, it's something to think about. Things arranged into territories. Simple four-word phrase, but go ahead and write it down, because everything I'm going to say hinges off of this. So when we talk about things, things are the objects, and we use visual encodings to flag or mark up objects in different ways. And we talked about category, precise quantitative info, general qualitative info, sequence. Those are attributes or types of functions of visual encodings, right? There's actually a lot of good videos and good research and books and things on that topic. So if you want to learn more about visual encodings, there's lots of stuff on the internet. Search that phrase. You can find some good YouTube videos, some conference presentations on this. There's good stuff on that. When you talk about the substrate, there's actually very little talking about how to come up with a substrate, how to create one. There's lots of books that say, here's 50 substrates, pick one, and they won't call them substrates, they'll call them something else. But there's very little talking about how to create it. What's the visual language? In fact, the stuff that is talking about it, it's in academia, and you have to kind of know where to go. So the way I think about this is I think about the things arranged, so the arrangement of the things themselves, and let's call that spatial positioning, so how you're spatially arranging things. And then once you've arranged things, the territories they're arranged into and defining those. So you have things arranged and into territories. And let me explain this will make sense. So there's a toolkit I've been developing, and those of you at the table have a copy of that. I'm calling it the Spatial Thinking Toolkit, and it's a way to make sense or understand how we arrange stuff in space. And so if we start with spatial positioning, there's really two things to focus on. Those are the blue cards. In fact, those of you at the tables, if you want to pull them out, you may. I do have some, they're not the tile version, but they're an index card version. If you would like to look through these, just make sure you rubber band them all back together and make sure they end up in a set. I was up late cutting these out last night. So you're not left out. You can just pass it afterwards. So I have 6 sets of these. Just make sure they end up back in a set. All right. So the first 2 suits, I'm going to use like card game analogy. The first 2 suits have to do with arrangement and with sequence. And let me explain this really quickly. Arrangement. There are fundamentally 3, maybe 4, depending on how you slice it, ways to arrange things. There's interval or ratio. When I said 4, it depends if you split these out or not. For our purposes, I collapse those. There's categorical arrangement, and there's ordinal arrangement. Let me explain this using coins, all right? If I have a bunch of coins, and I sort them into a stack of pennies, a stack of nickels, a stack of quarters, oops. Okay. If I stack them into categories, that is categorical arrangement. And that's how we can do a lot of things. We just sort them into buckets. So if you did a visualization where you had a category for good, a category for unknown, a category for bad, you were using categorical organization, right? That was the element you were using. There's another way to arrange things. So let's ignore the silver coins. Let's focus just on the pennies. You can't see it, but I've actually arranged these by the date on the coin. This is ordinal arrangement. So they're arranged in some sort of sequence, right? So these are actually arranged based on the date on the penny. That would be ordinal. Now pay attention, because ordinal is very different from the next one. In this case, I might have like 3 pennies. They're all 1994, and then 1997, and then 2000. Like, you wouldn't know. I can't read it on here. I doubt you can either. But it's sequenced in the year order. If I was to put it on a scale, then we would have what's called interval or ratio arrangement. So if I said we have 1 2003, and we have 1 2005, and we have 3 from 2006, and you can see we have no 2004 pennies, no 2007, we've now put things on a scale. So things like temperature, time, things like that, they're on a scale. And at that point, you can start to see, oh, we have gaps, or we have a lot more coverage here. So the way you arrange stuff plays different roles in our understanding and what we can make sense of. So that's arrangement. So sequence is the next thing, and sequence is how you arrange those things. So there's 6 ways to sequence. I'm not going to talk about diagonal much because I'm still on the fence about whether to include it or not. But if we go back to this, if I arrange things from left to right based on year, not only is it an interval ratio arrangement, but it's also, the sequence is direction horizontal. And direction horizontal is one that's culturally dependent. Generally, we think of time as something, or things growing, but that's a very Western culture thing. It's because in our languages, we read from left to right. If you go into Arabic cultures, where you read from right to left, it's a little bit different. And then Hebrew is mixed up because you learn to read left to right, but you do right to left. So they think in different ways. So when we say, oh, it's natural to arrange things in a timeline going from left to right, in Western cultures, yes, this is very cultural dependent. Contrast that with direction vertical. Direction vertical tends to be universal across cultures, and what the association is, the bigger thing or the more powerful thing or the stronger thing goes, what do you think, top or bottom? Top, yeah. And this probably has roots in biology, because trees that grow tall and strong, kids that grow up, you grow up in age, you grow stronger, you grow bigger, like you go up, right? And that's a fairly universal biological thing. It's also weird, like as I did this to illustrate the example, it felt weird to arrange things up like this. Like, do you guys get that? Like, it felt better when it was left to right. Again, that has to do with sequence or time. There are certain things that fit certain arrangements better. Central peripheral. So again, going back to biology, think about our eyeball, and the stuff that's in the center that we can focus on is always the most important, and then stuff as you go to the edges is less important. And so you see that represented in visualizations like bullseye models. If you've ever done a bullseye exercise or a prioritization with a client, said put the most important things in the center and the less important things in the ring and the least important things in the farthest ring. That's based on this idea of central peripheral sequence. So the most important things go in the center. It'd be really weird if the most important things were on the outer edges and the least important were in the center. It just feel odd, because it kind of goes against like just how our eyeballs work and how we focus on the important stuff. There are some others. There's spiral and circular. They are different. So we see lots of circular models all the time. Like in business, you'll see a business life cycle diagram and how things work, and it's a cycle that repeats. The clock or seasons are a type of cycle, a circular cycle. So I love this infographic because it shows which fruits are in season when. And it has this, so you can follow this around for a whole year, and you've got the different seasons and which fruits, the fruits are the color coding, but it's using circular sequence. Spiral's a bit different. Spiral says it follows a cycle, but it doesn't start over again when it comes back. It follows the cycle, but then there's a change, like you've refined things or things have improved, so it's a spiral, and eventually you get off the spiral, right? So this is an education model, it's a process model. You don't want to stay in this cycle or this spiral cycle forever. Eventually you want to release something, right? Or you want to learn something and get mastery. So the spiral's a bit different. So, and again, I'm skipping diagonal, but I think you can figure that out. So those are some of the core ways to understand arrangement of things. The other, let me go back, that spatial positioning. So into territories, once we've arranged things, then it begs the question, do we draw hard lines between them? What's the shape that contains them? So these are the spatial properties. So there's 4 suits here. We have shape, we have boundary, we have relationships, and then we have a bunch of these, let's just call them effects. I call them attribute intensity. I'm still figuring out the exact label, but these are visual treatments to highlight certain points of data. So let me walk through these really quickly. Once you arrange stuff, you can choose, do we use shapes, squares, circles, what have you, to represent it? Do we use a metaphor? Something like a tree or an iceberg. How many of you have been in a business presentation where someone used the iceberg model? Like, here's the stuff you see, here's all the stuff below the water. Yeah, very, very common model. And then figurative. And let me go through these really quickly. Most often, geometric shapes are what's used in our models. I tend to start with circles first. The reason being is by nature of not having a side, a circle doesn't suggest meaning. The moment you have a square or a triangle or a shape, people are saying, well, what do the sides mean? What's the meaning? Circles avoid that altogether. So that's why I like to start with circles in mind. But all of these are geometric shapes, and the shapes carry with them their own connotations. Figurative, whoops. So literal, symbolic. So I mentioned the iceberg, I mentioned trees. This was a model, an infographic or a poster I created a few years ago. And the main concept that I wanted to highlight was kind of like with the iceberg model, there's a lot of stuff below the surface you don't see, and there's the stuff above that you do see. But I wanted to call to mind that from a process point of view, if you don't prioritize the stuff that's not seen, then you're planting tumbleweeds that will blow away, right? You want to think about the roots and the things that go deep that anchor all the stuff you see. And so these were deeper considerations and things that go unnoticed, and this was stuff you actually see, and it was a kind of a UX model. But I used this floating chunk of earth to eventually show the stuff you see and the stuff you don't. So similar to the iceberg model. And then figurative is the last one. And this one, a lot of people don't use intentionally, but they use unintentionally. And what I mean by figurative is the type of squiggles and the type of shapes you pick suggest meaning. And so I picked these 2 shapes in particular because it's a study that's been around for over 100 years now called the Booba-Kiki effect. It's been tested across cultures around the world, and 99.9% of the time, when you ask people which one of these is Booba and which one of these is Kiki, they give the same answer. Anyone want to guess which one is Booba? Right? Yeah, and the Kiki is the one on the left, and that's just the shape of our mouth and these universal aesthetic responses, like our mouth sounds like that looks, right? So oftentimes I don't find people using this intentionally. I find myself asking people, why did you use squiggly lines here? Why did you do this? Because that suggests something that maybe you didn't intend. So boundaries. Boundaries are interesting, and this work comes straight from linguistics and categorization theory, but basically there's 3 ways to think about boundaries. Bounded set, fuzzy set, centered set. So bounded set, there is a clear definition. You either are this thing or you are not. Like it's black and white, right? A fuzzy set says, okay, this is the rough description, but occasionally we have things that don't fit this, and that's okay, right? Or we have fuzzy boundaries. And then centered set's interesting in that there isn't a defined or even general or prescriptive definition. You know an example, the exemplar. The classic example from linguistics is when I say bird, a lot of you think of like a little bird sitting on the tree, hummingbird, things like that, blue jay. But when I said bird, very few of you, I doubt any of you thought of a penguin, right? But a penguin is technically a type of bird, but it's not that centered set. It's not the archetype that we think of. So if we go to Venn diagrams, that's a bounded set. So I love this diagram. It's a Venn diagram of superhero comic tropes. I'll just let you appreciate that for a moment. Underwear on the outside, tragically dead parents, cape. And you can see which heroes fit in which category. So very clearly a bounded set, hard edges. Something like this. So it doesn't have to have the literal dotted line, but this is, you've got your X and your Y matrix, and then you've got gradation or shading. Because they're shades of things, and this is like the ideal, I would call this a fuzzy set. And so you're looking at things that are closer to the ideal or farther away from it. And then centered set in visualizations, I often don't see it by itself. Usually it's in pairing with something else. So this is a model from George Caillou, I think. He talked about play, games, fun, these types of things. And he talked about Paida and Ludus, so play and games. And it's hard to define play and hard to define games. They're like fuzzy things. They have, so you can know what a game is, you can know what play is, but if you start to draw the lines, it's really hard. And so he describes exemplars of those, but then puts them on a continuum. So that'd be a good example of two centered sets, one for play, one for games. Relationships. So if you ever took a logic class in college, you learned about circles and overlapping. This is that stuff. So you have common, overlap, you have contained, you have precedent, antecedent. So that means the sequence is important. This has to be before this one has to be after. Sometimes the sequence is important, but they need to be adjacent. Like you don't want them floating around. It's important that they be side by side. And then sometimes you have a literal connection. So this is the abstract pattern behind all relationships. And then attribute intensity are things like messing with the shape, showing transformation, adding curves, distorting things. Think of these as like effects that you can apply to highlight certain kinds of information. So that is the visual language that I've been deciphering and kind of identifying that I would argue rests behind nearly every visualization. In fact, I'm challenging myself and challenging you to find visualizations that I couldn't identify these elements in. And if so, then I'm like, I use that to improve this project. Take a moment really quickly. This is most useful as a deconstruction tool. Take a moment, like just 60 seconds, to look at one or two of the models that you came up with and try to deconstruct and see which elements you used in your model. I'm willing to bet most of you used direction horizontal, direction vertical, one of those two, and you probably used probably an ordinal arrangement. Those are the two most common things, but take a look real quick and try to identify some of the elements you used. I'll give you about 2 minutes for this. All right, I just heard two of my favorite words went paired together, fun and useful. And that's exactly what I want to do, is give a playful way to sort of engage with this kind of more conceptual stuff, like a way to think about the patterns below all of the visualizations we see. So next time you look at a Gantt chart, you're gonna look and you're gonna see, okay, ordinal arrangement, you're gonna see all this stuff, right? And that's my goal, is to help you see the patterns in the models that we use every day and we consume, so that we in turn then can create these models. And that's my theory, is the more we deconstruct and see the patterns, the more then we can turn around, create, and mix and match in our own ways. So think of these like Lego bricks, if you will. We can combine things. So let me take about 5 more minutes. We'll actually end a little bit early, but let me give you one other kind of a 1, 2, 3, 4, 5 step how to approach these things. So this is substrate stuff, and this is visual encoding. So this slide right here kind of sums up a lot of what we've talked about. And I'll give you access to the slides and the handouts. I'll give you a link in a moment to that. But this is the key idea. So things arranged into territories, things are visual encodings and they have properties. Things arranged as spatial positioning into territories, there are spatial properties. So this is like the keystone, or that I have arrived at, that's like everything's fallen into place for me when I started looking at things through this lens. The natural question then is, okay, well, how do we actually apply this? Like, this is good for looking at something and deconstructing it, but can I use this to create things? And so I just wanted to end with this kind of 1, 2, 3, 4, 5 step, an example. So stepping back across a lot of the problems I've done, whether it's reports or data visualizations or concept models or infographics, there's kind of this rough pattern that I go through. One, you want to identify the things. Now, I did this for you. The things in our challenge were the mutants, right? Those were the objects, if you will. They were mutants. And then you want to inspect the properties of each thing. So I actually, because we're short on time, I defined those properties for you. But you could imagine if you were starting out, you might go look at 50 different mutants, you might look at different types of powers, and out of that work, you might end up with a 1 through 5 scale, you might end up with those things. But I did that work for you. I inspected the properties and called out 5 that I thought were important for our exercise. Then you would arrange the things based on those identified properties. You've done that in this workshop. And then if we had more time, you would clarify the territories, and then you would keep or remove things. You would iterate and edit as appropriate. So an example of this, and I grabbed 2 very different things. These are from my brainstorming earlier, comparing Android phones, right? So that one is actually fairly easy because the things are all very similar. They're all Android phones, and they all have unique properties. And so it's a little bit easier than, say, how to prepare the perfect cup of coffee. Because how to prepare the perfect cup of coffee, it's not a problem of comparison. You're not comparing phones. You're actually looking at the different stages or elements of something. So that with a coffee, when you dive in and research, you learn the things to think about. The properties are beans, and there's a whole bunch of stuff there, grind size, the brew method and the filter, the bean to water ratio. But you notice these are all complementary things, where these are all parallel things, but they're all things to identify and inspect. So I put those side by side because it's easy to talk about this, and then you go to create a model in this, you're like, Stephen didn't tell us, like Stephen didn't prepare us. Let me take something really nebulous, play, fun, and games. It's the one I mentioned earlier. And if you were to brainstorm all the things related to that topic, you might end up with all of these types of games or play. So heads or tails, games of illusion, theater, swinging, waiting, checkers, all these things, right? And then if you were to start to arrange that or inspect each one at a time, you might come up with unique properties for each. So chess, as a game, has 2 players, right? No more, no less. It's competitive. It's a strategic game. It's turn-based. It's played on the board with pieces. There's no chance. It's all strategy. It's not a simple game, right? And you would do that, for one game. Then you go on the next game, hopscotch, and you would identify properties there. And it's a lot of laborious effort, but you're inspecting each and every thing to look for patterns that can then inform what you would do next. So continue with this example. I'm butchering his name because I can't remember it, one, and it's French too, but I think it's Roger Kelly, correct? This is being recorded, darn. But he did this exercise, and he ended up with basically these categories. So if you think about arrangement, categorical arrangement, and this continuum from play to games. And he put things like just spinning and stuff. Actually, let me put the labels. He think games of chance. He had one category, games of mimicry, and another, games of vertigo, where it just excites the body, sports and things, games of competition. And he put all these in a model that was published in like the 50s, I believe. Really great model. And that's how he approached this topic. And if we were to deconstruct it, we've got categorical arrangement of things. These are bounded sets, so they're hard lines. He used geometric shapes, rectangles. Distance matters, so whether they're up or down, and the distance is actually on this continuum on the vertical continuum between two centered sets, Paida, which is play, and Ludus, which is games. And then the adjacency actually means something. You can't just flip the relationship. He actually sequenced these in a certain way so that you could have games that straddled these fences, but if you change the categories, that wouldn't work anymore. So that's how he set up his model to explain play, games, and things like that. So that's kind of the process I use, generally speaking. This is the model, if you will, to pull it all together. If you're interested and you want more information about this, if you go to Poet Painter, which is my site, poetpainter.com/tiles, you can sign up for a mailing list. I will, probably at the end of the week, everyone who signs up on the mailing list, I will send you links to a print and play version of the tiles, to the visual encodings worksheet, and some of the keyframes from this presentation. So you'll get all that stuff later in the week. And with that, thank you very much.
I sat through this workshop about a month ago, and in that time period, I've learned so much more, and he has developed it even much more. So I'm really looking forward to the book and to when you develop this. On Thursday evening, Steven's going to be sitting on a panel with 2 other user experience experts, and they're going to be providing feedback to startups on how they can improve their products. So that's going to be Thursday at CoWork at 6:30. So if you've enjoyed this, come and see the advice that he has for those startups, but definitely sign up for this. And thank you for coming to Dallas Startup Week. Do you want to take a couple of minutes for questions? Or yeah, great.
And let me put it back. So that says I've got a book in progress. I wrote a book, and I self-published the mental notes, which I'll answer before it gets asked. Yes, they will be reprinted. There will be a Kickstarter project to reprint those before there's a Kickstarter project to make these tiles a reality. So I'll answer that one. I'll cut that one off the pass. I'll go back to this because this is probably the more important link if you were interested in this stuff. Yeah, any questions? Yeah, Brandon.
So how are you using these tools and this knowledge in your thinking?
Yeah, so for me, I think it's stuff I kind of knew or learned but didn't have a name for. And so it's helping me, one, understand it and label it for myself so I can be more intentional about things I do sort of naturally or I picked up in natural ways. But then more importantly, I'm always trying to help and train people with how to do visual models. And I find when it comes to visual thinking, some people just get it and do it and kind of can soak up patterns and do it well. And other people really need tools and training like this. And so I've been trying, I did a workshop on closely related topic in 2007 in London, and I remember it being just a disaster. Like I was like, well, look at all these ideas and get inspired and you'll figure it out. And I needed to do something more constructive. And so this is the fruit of that labor, is to really turn this into a teaching tool. My background is actually teaching. I used to be a high school English teacher 22 years ago. So I love teaching, love sharing, and this is a way to deconstruct something that I do into a teaching tool so that everyone can do it. And I feel strongly that much like writing, being able to express yourself in a visual way is really a literacy that we should all have. And so anything I can do to help people communicate ideas, especially complex ideas, using a simple sketch or a picture, like that to me is a win. Yes? I have not worked with AutoCAD. Photoshop, Illustrator, but no. Other questions? Yes. Sorry. Related to this stuff? Yeah, I mean, there's dozens of ways I could answer that. So there could be sites that employ this in subtle ways we don't notice. Like you would never call them a visualization site, but they're using arrangement to guide the eye. None that I can refer to offhand. Then there are sites we can go to actually see infographics and data visualizations. Not the site itself, but as a source of inspiration, I stopped keeping stuff in a folder and started pinning things on Pinterest, because Pinterest in turn like recommends more stuff. And so I don't know, their algorithms. If you just start off with, actually I have search for this. There are other boards I think that might have this name, but I have a board called the Visual Display of Information. I tried to avoid infographics or data viz, but the visual display of information. And anytime I find something new or novel or unique, a way to represent information, and I don't care if it's a poster or an interactive visualization, like I'm really looking for patterns. I pin it there, and then usually other stuff gets repinned. The three most recent pins, I don't know why it never occurred to me, but are all related to the periodic table of elements. And it's one of those things I learned growing up, but I really didn't get it. And lately I've been deconstructing that using this, and it's actually really quite elegant, the periodic table of elements and what they do. And so I think the three most recent pins are all different lenses or ways to look at that. But that's a very powerful visualization, and it's a tool that's used, in science and by scientists and chemistry students every day, right? All right, I think one more question, yeah. What are some of the more creative solutions to the mutant problem? Gosh, I'm having trouble, and you're talking more about the model one, the substrate one. With what? With the mutants, yeah. I see some really creative ones, like with the pens that are out of the box. Oftentimes, the danger I see is information overload. So I'll see stuff where there's a lot of noise, and so if I was scanning stuff, I'd have to, one, see the thing, but then decipher, filter out the noise. And it's easy to go in that direction when you're asking too much of a little pen. On the model, I'm trying to remember, this is probably a comment in itself, but there are none that come to mind that were really powerful. And I think just even whether it's 12 minutes or whether it's an hour, it's hard to come up with that novel thing. Usually I see people falling back on rectangles or maybe a Venn diagram or like these common patterns, because they're safe and you can explore and play with stuff like that. I'm trying to remember, there were some creative ones that rolled in a theme or a metaphor, like with the intensity and the power level. I can't remember exactly, but I remember that being one of the responses. All right, well, thank you all very much. Enjoy Dallas Startup Week. Thanks for coming. Oh, and if you're sitting at a table, please pack up the tiles for me and put them back in the Ziploc bag. And if you ended up with one of the sets of tiles, just make sure the set is rubber banded, and I'll collect that from you.